Kita Bbosa science, kwano kwa beti science, love ya Bbosa science, truth na beta, truth na omega, truth na alpha science.
The Science Foundation College enamave ku Lwejjinja ng'oyingira kilomita emu. Ssomero lya Dene Boarding ery'abawala n'abalenzi. Ku O-level tusomesa arts ne sciences ate A-level tusomesa sciences zokka. Omwana mulete ku The Science Foundation College. Ffe tusinga okusomesa sciences. Okumanya ebisingawo kuba ku 0753 8 27 09. The Science Foundation College, based on sciences and based for sciences.
Amines, these are alkyl derivatives of ammonia. Classification according the number of alkyl groups attached to a nitrogen atom. Primary, amines have one alkyl group, i.e. RNH2. Example is CH3 CH2 NH2, which is ethyl amine or amino ethane. Ethane has got only 2 carbon atoms, so we don't have to indicate the position of the amino group. Secondly, amines have got 2 alkyl groups attached to a nitrogen atom. Example, if they are different alkyl group, we name them alphabetically. This is ethyl, methyl amine. A methyl group and the amethyl group are attached to a nitrogen atom. Here 2 methyl groups are attached on a nitrogen atom. Tertiary amines have got 3 alkyl groups on a nitrogen atom. Examples, that is methyl amine, or we can have this is ethyl, methyl, phenyl amine. E comes before M, comes before P. Ethyl, methyl amine. Physical properties of amines. A. Amines have higher boiling point and melting points than non-polar compounds of similar molecular mass, because amines associate through dipole-dipole interactions. Amines are polar compounds, so they associate through dipole-dipole interactions. B, primary and secondary amine have higher boiling and melting points compared to tertiary amines, because for them they can associate through hydrogen bonds. They have a hydrogen atom attached to a nitrogen atom, so they can associate through a hydrogen bond. A hydrogen bond is a bond formed between hydrogen attached to electronegative atom and another electronegative atom. Compounds associated by hydrogen bond have high boiling and melting points. They are soluble in water. They have a higher viscosity. C, primary amines have higher boiling and melting points compared to those of secondary amines, because primary amines have got two hydrogen atoms on a nitrogen atom, and thus can form more hydrogen bonds compared to the secondary amines that have one hydrogen atom on the nitrogen atom. 2, solubility in water. Amines are soluble in water because they can form hydrogen bonds with water. Basicity of amines, like ammonia, amines react with water to form alkaline solution. This property is due to presence of a lone pair of electron. So ammonia uses a lone pair of electron to attract a proton from a water molecule to form ammonium ion and OH ion. The formation of OH ion means formation of alkaline solution. Groups like alkyl groups that release electrons to a nitrogen atom increase the basicity of amine, because they increase the density of electrons of the lone pair of electron, and thus increase the ability of a lone pair to pull a proton from water to form more hydroxyl ions. If the density of a lone pair is high, to be able to pull easily a proton from water, forming a hydroxyl ion, thus a stronger basic solution. The order of basicity of amines is ammonia is less basic than primary amine. Primary amine and tertiary amine almost have the same basicity, and they are less basic than secondary amine, because 1, alkyl amines are stronger bases than ammonia, because the alkyl groups push electrons to a nitrogen atom and increase the ability of a lone pair of electrons to pull a proton from water. 2, secondary amines are stronger bases than primary amines, because secondary amines have got two alkyl groups pushing electrons to a nitrogen atom, while primary amines have got one group pushing electron to a nitrogen atom. Therefore, the electron density of a lone pair of electron on secondary amine is higher than that one of a primary amine and is able to pull protons from water, forming hydroxyl ions. 3. Tertiary amines are weaker bases than secondary amines because the ammonium ion formed when tertiary amines react with water is unstable, i.e. when tertiary amine reacts with water forms ammonium ion which is unstable, so the equilibrium rises over to the left, forming fewer ammonium ion and fewer OH ion. Groups like a phenyl group that withdraw electrons from a nitrogen atom make amines weaker bases than ammonia because these groups reduce the electron density of a lone pair of electrons on a nitrogen atom. Thus, its ability to pull a proton from water. The question will be, explain the trend in the basis of amines below. Phenylamine is a weaker base than ammonia. Ammonia is a weaker base than dimethylamine. We have already seen that the phenyl group withdraws electrons from the nitrogen atom, reducing the density of a lone pair of electrons and its ability to pull electrons from water to form hydroxyl ions, which makes it a weaker base than ammonia. In the methylamine, the two methyl groups push electrons towards a nitrogen atom. This increases the density of a lone pair of electrons and its ability to pull protons from water molecules, forming hydroxyl ions, making dimethylamine a stronger base than ammonia. Chemical properties. 1. They react with acids to form solids. For example, methylamine plus HCl, you get a solid. 2. Primary and secondary amines react with alkanoyl halides to form amides. For example, methylamine react with methylamine react with ethanoyl chloride to form amide. Mechanism. This one, amine is the lone pair. The double bond breaks. The positive charge comes here. The negative charge comes back. This one goes. So we subtract HCl, we get search field. Example 2, complete and write a mechanism. You pause, complete, then write a mechanism. We hope you got. Mechanism. The amine uses the lone pair of electron to attack at the carbonyl group. This bond go. With a positive charge. The negative charge come back, and this one will go. You get an amide. You get an amide. 3. Primary amines undergo condensation reactions with carbonyl compound. Example. Mechanism. Uses the pair of electron to abstract a proton. The positive charge goes there. This one will go. That one will go. Then there's a proton shift. The positive ion jumps from here to there. You get nitrogen uses a pair of electrons to form a double bond. This bond breaks. Positive ion comes there. Then there's a loss of a proton. Then you get not the movement of a positive ion from here to there, to here, to here, to here, until it is subtracted. Example 2, you can complete and then write a mechanism. You'll observe that the mechanism occurs on this carbon atom there and this nitrogen atom with 2 hydrogen atoms. So you'll get the 2 hydrogen atoms here and the OH ion form water. Then you get then the mechanism oxygen uses a pair of electrons to abstract a proton. The positive charge comes there. Hydrogen attaches on this oxygen atom with the positive charge. Then the ethylamine uses a pair of electrons to react with this carbonyl carbon. This bond go the positive charge comes here. Then there's a proton shift. The positive charge jumps from here to there. You get positive charge comes there. Then this one uses a lone pair of electrons to form a double bond there. This bond go. Then we lose a proton. You get that. Take example 3. These questions are very common. That's why I'm giving very many examples. So you pause, complete, and then write a mechanism. The reaction occurs on nitrogen atom with 2 hydrogen atom and the carbon atom with oxygen atom. So we get that one, mechanism. You abstract a proton. Not where the positive charge go. Hydrogen goes there with a positive charge. Hydrogen comes here with a positive charge. Then this uses a lone pair of electrons. Come there. This bond breaks. Then there's a proton shift. A proton jumps from this nitrogen atom to this oxygen atom. Then we get this one uses a lone pair of electron to form a double bond. These bonds go. This bond go. This hydrogen, and then a positive charge comes there. Then we subtract. Note that the condensation reaction occurs on a carbon atom with a carbonyl group and a nitrogen atom with two hydrogen atoms, not a nitrogen atom with one hydrogen atoms. The reaction is not going to occur this carbon atom. It occurs on this one and that one. Distinguishing between primary, secondary, and tertiary amine, the reagent is sodium. The reagent is sodium nitrate in HCl at a temperature less than 5 degrees. The temperature must be less than 5 degrees because at a high temperature, all the amine will give the same observation. Primary amine, gives a colorless solution, give colorless solution with effervescence. Effervescence. Example: ethyl amine plus sodium nitrate plus HCl will give you Cl plus water plus sodium chloride plus nitrogen gas. Ethyl amine plus sodium nitrate plus HCl will give you chloroethane plus water plus sodium chloride plus nitrogen gas. Nitrogen gas is the one which is seen as bubbling gas. Secondary amines give a yellow oily precipitate. For example, dimethylamine plus sodium nitrate plus HCl less than 5 degrees, you will get a yellow turbid solution of a nitroso compound. Tertiary and aromatic amines. Tertiary and aromatic amines give a colorless solution. Example: trimethylamine plus sodium nitrate plus HCl less than 5 degrees Celsius, you will get methyl diazonium chloride. Preparation is of amines by reacting alkyl halides with ammonia. Example: mechanism. This being a primary alkyl halide, it undergoes SN2 to get minus H plus, you get NH2. Example 2, 2-bromo-2-mesylpropane plus ammonia, you get mechanism. This being a tertiary alkyl halide, will first lose the bromine atom. Get a positive charge, you subtract a proton, you get NH2. 3, by Hofmann degradations, amine with no substituents on a nitrogen atom, react with bromine, react with bromine or chlorine in the sodium hydroxide to yield amines, i.e. amide plus bromine plus sodium hydroxide will get an amine. Example: note that the amine formed is one carbon atom less than the parent amide. Note that amine formed is one carbon atom less than the amide from which it is formed. By reduction of nitriles, example: The question may be synthesize amine from ethine. Then you think of roots from ethine to this one. You have to add on as a carbon atom. One, we have to add on a carbon atom. So we start with this one. We can reduce it to then you can convert this one to then you can reduce this one to what? You can reduce this one to so what do we add here? We saw that when we use the palladium and hydrogen, we reduce a triple bond to a double bond. Then you can add HCl. Then from here to here, we saw that we can add the potassium iodide. Then from here to here, we have seen you add the lithium, aluminium hydride, dry ether. You can also convert this one to this using platinum and the hydrogen. Then you can convert this one to this one using the chlorine, UV light, and then you convert this one there. Or you can also convert this one to then this one we convert it to convert this one reduce this one to change this one to OH, change this one to then change this one too. So think of the reagents which you can use, converting this one to this one to that, this one to this, then this one to that. Thank you very much.
Omukyala kyakufumbira kyolya, omukyala kyakufumbira kyolya, naye lwaki mono ku moto womala kuyomba, mono ku moto womala kulwana, mono ku moto wotujereka, lwaki wangana okulya mu kyalo, lwaki woza simala kolimba, olusi wogifumbira waba kulwaza, olusi wogifumbira waba wakyamu, omulungi atanabakanyiwa n'obutayoza kiba kikyamu, entikko y'omukwano kisenge, lwaki naye lwaki mondo ku mutu womala kuyomba, mondo ku mutu womala kulwana, mondo ku mutu wotujereka. Lwaki wangana okulya mu kyalo, ofumba okwagala lisaaki okunyuma, wange ensiba mu lisaaki, mondo okumukutandwawo, mondo okumunyima ntabuka, mondo okumuzima kuba, mondo okuwomerwa kiva ku mazzi. Wetegekere muno onfunira akaseera akamala, ozanyisa omutwe ogwanyumirwa, wagazanyisa mipiira anyumisa, zanyisa baluni, zanyisa amabeere, lusinyoka n'okuyonka anyumirwe. Faayo, faayo. Omukwano gwagala kuyiya, ofumba ogwagala lisaaki okunyuma, wange ensiba mu lisaaki. Bweruba oluganda asobola okuwasa omukyala abawuwo, njagala omukyala abaawo, betita yombayomba, betita nyiganyiga, betita ganagana. Bw'oyagala akawunga abaawo, oyagala omuceera abaawo, ennyimba z'omupiira asobola, anyumisa, nyumirwa, nyumirwa omukwano gwe. Mondo ku muntu womala kuyomba, mondo ku muntu womala kulwana, mondo ku muntu wotujereka. Lwaki mondo ku muntu womala kuyomba, mondo ku muntu womala kulwana, mondo ku muntu wotujereka. Lwaki